Hello, this is Dr. Scott Dennstaedt, founder of EZWxBrief, your best online source for aviation weather and education. Welcome to episode 19 of EZWxChat, a program to discuss various topics related to aviation weather. Thanks for joining again. In this episode, we're going to talk about a specific topic called model output statistics. Model output statistics, also known as MOS. Now, model output statistics has been around for many, many decades, since the 60s, when forecasters or meteorologists realized that a lot of the models that were written many years ago, some of the initial forecast models that were used, could not predict weather for particular sites, so for a particular city or airport or town. And as a result of that, model output statistics was born. The idea was to get data out of the model and produce a site-specific forecast that was useful. And of course, when you look at weather in general, aviation has a big part of where we are with respect to weather. Some of the initial forecast models were built primarily to help pilots, mostly commercial aviation, be able to get from point A to point B safely and do it efficiently. And model output statistics is just another example of that, to be able to provide accurate, fairly up-to-date recent information on the possibility of what the weather's going to be at a particular airport. And so what we're faced with in any scenario when we fly from point A to point B is not only knowing what's happening en route, but also what might be happening at our departure airport, but mostly what's happening at our destination. And certainly there are a lot of different products out there to use to be able to figure that out, but terminal forecasts, for instance, are probably one of the most used forecasts out there by pilots because they're very detailed and they are very specific to aviation. And so from that standpoint, they become a valuable asset to pilots to know whether or not I'm going to have to do an instrument approach to the airport, whether I can fly VFR to that airport, or whether I even should depart an airport, and terminal forecasts come into play. But terminal forecasts are not at every airport. Around 700 or so in the US, and that leaves thousands of airports without a specific forecast for aviation. And it's not a great idea to use the closest terminal forecast, the closest TAF to the airport you're going to, because weather is very local sometimes. And in fact, forecasters tend to kind of stack the deck in their favor, and they only forecast for a 5 statute mile area around the airport. I talked about this in a previous episode. But it's important to understand that using the closest TAF may end up producing a whole different set of weather depending on where the airport you're concerned about is and where that TAF is located. Wind, ceiling, visibility all can be significantly different, even 10-15 miles away. And so forecasters, especially with respect to convection, are kind of banking on that smaller forecast area to get their particular forecast correct. So for example, if there's an area of weather that's moving through the region and it may be convective, if it's very scattered or isolated, most likely in that region where that terminal forecast is, you may see a situation where they're only forecasting showers or showers in the vicinity. It may not even be forecasting thunderstorms, but maybe a nearby airport has a lot greater chance or risk depending on, again, the weather that's evolving and how it's essentially how it's forecast by that meteorologist. So in the end, not a great idea to try to use the closest terminal forecast. So model output statistics is a product, like I said, it's been around for many decades, that's starting to recently get more notoriety in the aviation world. I certainly have been a pilot for over 20 years and have been using it day one, at that time there was a couple of different model output statistics products out there, and they've changed over the years for the better. But the primary and reason for having this is that forecast models produce a really good forecast, but don't produce site-specific information, and sometimes don't produce information that's specific that pilots need, like ceiling and visibility. So those elements have to be kind of derived from model data, and it has to be essentially forecast for that particular airport or town or mountain pass, whatever the case may be. And so the goal for model output statistics is basically to take the model data, the model forecast from the GFS model or from the North American Mesoscale model, using geoclimatic data, able to then forecast for what's happening at a particular airport. So for instance, let's use wind as an example. When we're looking at wind, we know that wind is basically a response to pressure gradient. So let's say the forecast model comes along and expecting a certain pressure gradient in 12 hours from now, and a certain pressure field, how it's aligned. Well, we can essentially use that model data for that pressure field and kind of look that up and say, when the model is producing this kind of pressure field, what are the winds typically in that situation at the airport? So by comparing years and years and years of observational data kind of set up, then at that point in time it now essentially knows what, based on a certain pressure pattern, what the winds will likely be. And we know that wind especially is very much dependent on terrain. So if you're have an airport that's near a river or next to the ocean or on a mountaintop or in a valley, that's very important to know. And so model output statistics kind of has that all wrapped into it, because it's using observational data from years past to develop a set of equations so it understands what the weather will do in certain key model fields. So it's able to draw that information from model fields and convert that to actual wind forecasts. And it sounds very complex, but it's actually quite easy. It's run essentially after the model is finished. So we have many, many models out there, and you can go up to the the National Centers for Environmental Prediction website and go to all these models. These are also all available, well, not all of them, but some of them are available in EZWxBrief. But let's say we look at the GFS model and we look at the CONUS area, and essentially we can pick any particular field here. Let's use the 850 millibar temperature, mean sea level pressure, and precip. And when we look at this, again, the model itself that's producing this kind of pressure field, that's these isobars that you see here. And that's going to be all drawn into the model output statistics program once this model has finished and is completed. So essentially, when this model has finished its forecast, it's now available for the model output statistics program to run along post-process, if you will, and then grab this information and produce its forecast. It doesn't really take all that long to do, and then it'll produce a forecast valid at various different stations, and then that can be gridded into a nice, neat looking map. So there are two basic model output statistics products that are available in the US. That is for the GFS, the Global Forecast System, and for the North American Mesoscale model. And again, these have been around for a long time. The GFS MOS has a really long history, way back when it was called the aviation model many, many, many years ago. And the North American Mesoscale model as well, dates back into the 90s. So These two products have a really nice track record over the years, and they're pretty darn good overall. Once again, those two models essentially will be run, and then the MOS products come afterwards. So they take a little bit longer to come out, but nevertheless, when they're there, they provide you with site-specific information. Now, they don't forecast for every possible airport out there. There's a subset because every single airport has to have a specific set of equations developed for it. But nevertheless, you're looking at about roughly 2,000 airports, of which the 700 airports for terminal forecasts are in that 2,000. So you've got like 1,300 additional airports with good site-specific information. And again, this can be gridded, so they can take all these site-specific parameters and then grid them and produce a nice-looking map. And we'll see that in just a bit. So the important aspect of this is to know that the goal is to produce aviation-specific forecast information like ceiling, visibility, wind, even probability of precipitation or obstruction to visibility. All those kind of things are part of this, and to produce that at a particular airport. So if we go get the GFS MOS bulletins, we can pick from a number of things. I know this data input has a lot of information on it, but we can essentially look at any of the bulletins for specific stations. So if I wanted to, for instance, look at KMSP, I can do that. So I can look at the short range MAV, which is the GFS model. So the GFS MOS is called the MAV. The North American Mesoscale MOS is called the MET, M-E-T, that you see over here. So if I wanted to get those bulletins for both the MAV and the MET, I could do that. Essentially, I put in KMSP and I want to view the bulletins for that airport, and here they are. So you notice they're tabular. They're just a string of text, if you will, but ultimately you can get a lot of good information about what's going on at that particular airport, including cloud coverage, so things like, for instance, scattered clouds or sky clear, few or broken. You can look at wind direction, wind speed, and this is in knots for wind speed. You can also look at ceiling and visibility. Now, you have to know that you have to have a magic secret decoder ring for this, because these are categorical. So these are not absolute ceiling or visibility numbers. They're categorical from that standpoint. And I'll show you that in just a second. So you notice that the MAV itself, this is the 12Z run of the model. The GFS MOS is run 4 times a day, whereas the MET, or the NAM MOS, is actually run twice a day at 0 and 12Z. But you'll notice that it produces a forecast every 3 hours, essentially. So we have a 3-hour forecast all the way out to a total of 72 hours in the future. So it gives you about a 3-day view of the weather at a particular airport. And of course, again, this is updated for the MAV, it's updated every or 4 times a day. So it's going to be at 12Z, 18Z, 0Z, and 6Z. Again, it's not going to run exactly at those times because it takes a while for the model to complete. So usually the GFS 12Z run, you can give it about 4 hours, and then so sometime around 16Z it should be available. And then again, you can get good information with respect to temperature dew point, cloud coverage, and ceiling and visibility, and even probability of precipitation as part of that. Now, once again, the keys here are, if you look at the actual key itself for the MAV, you're going to notice that it's not, again, a situation where the ceilings and visibility, they're not absolute ceilings. So this is not an 800-foot or 8,000-foot ceiling here, but you actually have to use a decoding capability, and that is 8 means that the ceilings are basically unlimited or greater than 12,000 feet. So if we had seen a 4, that would mean the ceilings were in this range. So it's a marginal VFR from 1,000 to 1,900 feet. Or if the visibility was showing up as a 3, that would mean it would be somewhere between 1 and 2 statute miles. You can also see other aspects here. For instance, obstructions to visibility are also shown. You can see that here at the very end. So if there's no obstructions to visibility, you'll see a bunch of N's. But it could be that it's due to mist or fog or haze. That's also part of it as well. So pretty nice overall if you can do that decoding. Now some websites do a pretty good decoding of that. For instance, in Garmin Pilot you can get the MOS forecast and they will decode this into those ranges. Now some other sites may actually, instead of actually picking, showing you the range, they may decide, hey, anytime there's a 4, we're going to put 1,500 feet in for the ceiling. Or anytime there's a 5, we're going to put 2,500 foot in. So ultimately they may choose a specific number rather than showing you the range. And then also some websites will tend to take this and collapse it such that if, in this case, you see all the ceilings for the most part are unlimited, it's not until you get to 15Z on the 5th, in this particular case March 5th, that you'll start to see that, hey, the weather's starting to have some issues with the ceiling going down a little bit. And so it may take the times here that you see and they may collapse them so that instead of having, let's say 20 columns here, you only have 4 or 5, similar to what you would see in a terminal forecast. But keep in mind, if they do that, they essentially stray from the bulletin. They're doing some magic behind the scenes to make it more usable, but it may not necessarily match exactly what you see here in the bulletin. And once again, you also have the ability to see both the GFS and the NAM-MOS forecast, and you can compare and contrast. And the question I always get is, which one do you look at? Well, you can look at both. Certainly, you can side with the one that has the lowest forecast per se, or the worst forecast, and go with that. Or you can essentially also compare this, because ultimately at MSP, Minneapolis-St. Paul, you're going to know that there's going to be a TAF there and for that particular one, so you'll be able to compare and contrast it from there. So the FAA basically doesn't particularly call out that the GFS or NAV-MOS can be used, but there is one that actually is very similar. It's called the LAMP. The LAMP is called the Localized Aviation MOS Program. And it's been around for at least 20 or more years, and it has a very similar bulletin associated with it. So if we look at that bulletin here, you'll see that the bulletin is, in this case, it looks very similar, has the same kind of things. There are a few other fields that it produces. For instance, it will produce information for wind gusts, WGS. So if there are any gusts out there, basically anything that's going to be 14 or 15 knots or greater, you're going to see a wind gust shown there. But it also will produce the CCG or CVS, which basically says what is the ceiling if there happen to be precipitation. It's called conditional ceiling and conditional visibility. What happens if there are, in some cases you may see that this conditional ceiling will be lower. So if there is precipitation, expect the ceiling to be lower. And the visibility will be the same way. But the nice thing about the Localized Aviation MOS program is that it's run every single hour. And it produces a forecast, as you see here, out to 25 hours in the future. Or you can look at the 38-hour bulletin here, which essentially goes out further, but you're going to notice that it's not going to provide all the data, all the fields that are possible, all the elements in some cases. So you may find that certain situations you'll see lots and lots of 9s here, which typically means that they don't forecast out that far for this particular, for the LAMP product. But the nice thing about this is it does produce a hourly forecast for all the elements that we're concerned about as pilots. Now what LAMP is all about essentially is that it's trying to take the GFS MOS product, and it's actually gone beyond that, but initially when it was built, It was to take the GFS MOS and improve on it, because they said that the GFS MOS is run every essentially 6 hours. So that's not updated a whole lot throughout the day. So the goal there is to say, well, let's provide a product that will kind of take the GFS MOS and kind of update it every single hour. So it runs the GFS MOS, it aligns it, and it says, okay, now we've got another hour has gone by. Let's go out and look at all the various different observational data. Let's look at NEXRAD, let's look at surface observations, lightning data, all that kind of stuff, and let's pull that in and let's compare it against the way the GFS MOS thought it was going to happen. Well, wait a minute, it's straying from the, it's actually straying from the forecast is essentially straying from the actual data that's going on there, so it can kind of rein that in and improve upon it. So the lamp actually does much better in that first 6 to maybe 12 hours of time, because it's constantly updating based on the current weather. So you can think of the lamp as kind of an updated version of the GFS MOS. And so every single hour you'll get a new product. And that helps out because forecasters use all this data for their terminal forecasts. So it provides a great deal of information for forecasters to use. And again, LAMP is available out there, and it has the same kind of situation in terms of its the fact that it is in this particular case, still a categorical kind of forecast. So it's not going to necessarily give you specifics per se. It'll give you that categorical forecast. And it's forecast for just roughly the same number of sites out there, roughly around 2,000 or so. And again, there are some websites that provide this information, and the LAMP MOS product is something that is provided by EZWxBrief. So EZWxBrief, for instance, if you go to and pull up, let's say, Minneapolis, St. Paul that we're looking at, and you go to the selector here, and you can pull up the LAMP MOS product for that particular airport. I don't have a legend in here at this particular point in time, but you'll see again the same kind of look and feel for the 25-hour LAMP forecast. And this gets updated again every single hour. So if you're concerned about what's happening out there, LAMP is a great tool to kind of see what's happening for the airport, especially for airports that may not have a TAF. For instance, one of them I know is near me, Charlotte Executive Airport. There it is. There's no TAF there, but there is the possibility of getting information for that airport from a wind perspective, ceiling perspective, visibility perspective as well. Now the other aspect of this is that you can also actually look at the LAMP product, for instance, and look at it from a perspective of gridded LAMP, or it's basically a gridded version of that. So there's a lot of stuff going on behind this, but in the end, the product itself can actually then be looked at from a standpoint of show me what the sky coverage version is going to look like. And so it's not showing here. Let's see if we can find an image. There we go. So this would be the sky coverage. So anywhere you see kind of the bluish colors, we're dealing with, most likely we're dealing with scattered or few or even clear skies. Whereas you see the gray coverage, we're probably dealing with broken or overcast skies in that area. It doesn't tell you the ceilings, but there is certainly a ceiling product here. So we have ceiling height, we have visibility as possibility, and we have wind gust and wind speed, as well as that sky cover. So if we look at ceiling height, for instance, again, it gives us a really good indication using the scale that you see here. So purples essentially are dealing with low IFR conditions. We're dealing with kind of more reds being IFR, marginal VFR, yellows and blues, and then we go green for VFR, and again it gets to the point where if there's nothing there, then we're dealing with ceilings that are greater than 12,000. And it is a ceiling, so it's taking into account the mountainous and terrain features around it. We can also do the same thing for visibility. And we can also see things like wind gusts, for instance, so we can tell what's happening from a wind gust standpoint. And we can look at these projections and we can go out a total of 25 hours in the future to kind of see how that is progressing. So if you're headed to North Dakota, for instance, the winds are going to be fairly strong, somewhere in the, from a gusting standpoint, 20 to 30 knots. And you could, again, poke down there if you want to see what Bismarck looked like, or you want to go to Rapid City or International Falls, and you want to drill down on that particular airport. Again, you can go to the text bulletin and see that. So I could bring up, for instance, KINL, which is Minneapolis, or I'm sorry, it's International Falls, and then you can look at what the forecast is for that in terms of ceiling and visibility. You can see the ceilings are pretty good all the way until we start to get more into the 14Z to 20Z range tomorrow, and then you're going to start to see some more marginal VFR ceilings in that area. But the visibilities, 7 is basically unlimited, look really good from that standpoint. So that's kind of how you're likely to use the product overall. And now LAMP has actually gone through and is probably one of the more sophisticated of all the MOS products, essentially. And I say that kind of lightly, but ultimately it's gone through a lot of revisions over the years, and it's kind of what the National Weather Service is putting all their energy into at this point. Whereas GFS MOS and the NAM MOS will eventually kind of be retired, although it still will be used as an input. You just won't get access to it in the future. And certainly LAMP is a product that will be around for some time now. It also uses the high resolution rapid refresh model. It actually uses not only the GFS MOS now, but the NAM MOS, and it uses lightning data and radar data, NEXRAD information, as well as surface observations and those other models that I mentioned to create the product it does. And it actually does a pretty good darn job overall producing a forecast. And so that gives you the perspective in terms of what the product is. Again, you can look at this data, and if you go to the map page, for instance, in EZWxBrief, I don't provide the MOS forecast here. Instead, it's called the EZ forecast, and the EZ forecast here essentially has a forecast that incorporates both the LAMP and GFS MOS and NAM MOS and other weather models to produce the forecast that you see here. So when you're looking at this from this perspective, then when you look at each of these different sites to determine what's happening here from a perspective of the weather, then you click on this, for instance. This is basically ceiling at 300 feet, broken at 300 feet, 1 statute mile. Doesn't come from a single model, it comes from multiple models, of which the LAMP and GFS MOS and NAM MOS are models that I use to produce this particular forecast. And so you'll see this hour by hour all the way out to a total of about 66 hours out in the future. So I think I've been able to take the MOS forecast and other forecasts together and even improve upon that. Sometimes it'll match pretty closely because I lean or I have a bias more towards the LAMP product itself, so therefore you're going to see probably many situations for this to be matching pretty closely to what you'll see in the LAMP. So if you were, for instance, to take this and say, let's look at ACV, let's look at it from this standpoint here, the forecast for KACV, at that point go out and pull up that bulletin, KACV, and you'll notice here that yes, the ceilings here are down in the 2s and the 3s. That means that essentially you're dealing with low IFR conditions. So again, I would expect that the EZ forecast that you see should match fairly closely, but there are times where it might deviate a bit, especially with the wind forecast, which might be a little bit different for the EZ forecast that I provide. but nevertheless, it provides a good overall view of the weather. The last thing I'm going to talk about real quickly is simply that when you use this, you really should use it as supplemental information. So don't rely on it specifically. If a terminal forecast is there, you really should use the terminal forecast. It's just really to be supplemental to that. So can you use it legally? Well, maybe. Ultimately, I just put out a blog out there for this. So if you go to my blog, you'll notice that can MOS be used to determine if an IFR alternate is needed, for instance, or use it in your, it's pretty thorough, but ultimately you're going to see that if you go to the aviationweather.gov site and you go to specifically the GFA tool, you're going to notice here that it's showing ceiling and visibility, and it can combine those in the flight category. This actually comes from the LAMP forecast. And essentially the FAA has blessed us to be able to use that. So in respect, I would think that if you use this to determine whether there's an alternate or not, this would be a legitimate use of the LAMP product, not the GFS MOS, but the LAMP product for determining whether you'll need an alternate or even potentially alternate minimums in terms of what the weather will be for airports. But again, I would try to stick to the terminal forecast when that is the case, especially when you're looking at the weather for an alternate. That wraps up episode 19 of Easy Weather Chat. My name is Dr. Scott Dennstaedt, and as always, I hope you enjoy the simplicity of Easy Weather Brief.